up, we did 1, 2, 3, and 4. For 1 and 3, so each of these, they didn't tell us they were regular polygons, but the fact that we have those markings in here indicate that they are regular polygons. We really just have a triangle and a square. Now for number 1, they didn't give us the apothem, so we can just go and use our original formula for triangles, 1/2 base times height. But you do have to draw in that height, and oftentimes you have to do that. Some of us seem to just assume that there's a 90-degree in there. We usually have to draw in that to find it. But let's just go on a side note. If I had this triangle here, I gotta do my area. What do I have to do to find my height for this one? Isn't it just 3? Yeah, so I'm moving my base piece, Simon. Sorry, this is 4 here, and this is 5. 4? Good. Whenever we have a right triangle, 3, 4, there are already perpendicular sides. And we know that our base and our height have to be perpendicular. So when a right triangle is given to you, I told you guys this before, but I think some of us have forgotten that. When a right triangle is given to you, you don't have to do extra work to find your height. You've already been doing the base and the height. You just simply put that into your formula. When we don't have a right triangle, then we have to draw in that height that gives us that perpendicular to our base. Right? So your base and your height must be perpendicular. If it's a right triangle, just use those legs. That's already your base and height. Okay. Do we have any questions on 1 or 3? Those ones were the easier ones. 2 and 4 required a bit of work, particularly with our trigs. Let me do that before we do that. Right, so remember, area of the kite is 1/2 diagonal and diagonal 2. That's one of the formulas you have to have memorized throughout the entirety of the test and SWOT. That won't be given to you. So we had to first find, because we need our diagonal, so we only had this piece to read. So we had to find this remaining piece here, as well as this piece here. We know that in a kite, this diagonal gets bisected, so once we have this piece here. And you can just use Pythagorean theorem to solve for that. You get 6√2 for this piece, which means the whole diagonal is 12√2. This whole thing is my 12√2. And then to find my piece here for the whole diagonal, I had to use trig. We end up having to use tangent. Remember, in kite, our vertex angles get cut in half, so this is 54, each one is 27. And then because it's 90, our diagonals are perpendicular to kite, so 90 degrees will be equal to 63 here. So you could, I did tangent of 27. You technically could have done, you could have used your 63 degrees and instead used tangent that way, but you would have had the ratio drawn. So that diagonal was a little crazy. Our y value was 6√2 divided by tangent of 27, so I gave you some type of decimal, add 3 to it, and I gave you the whole diagonal. So our entire area is 166.8 units. And then for our trapezoid down here, they did tell us it's isosceles. That doesn't matter. We still use the same formula of 1/2 times our height. That was base 1 plus base 2. They gave us our base here was 10, and they told me that this was 3. Because we have its isosceles, that's what lets us know that this is also 3, and then our 10 in between here. So our bases were 10 and 16, and then my height, we had to use trig to find that. So I did tangent to get our height, and then our firebrands were 62.4 feet squared. Make sure you don't forget your units squared. Do we have questions on June?
So there wasn't any way to figure out the volume without using the factors of
No, you had to bring down the fact that was 10, making that rectangle there, and then that these two triangles were congruent, and that's the 3 there. Yeah, you didn't have any other way. Other questions with these?
What did you get for your tan?
What'd you say?
What did you get for your tan?
So I had 3 tangent of 58 degrees. You want the decimal for that? 4.8. 4.801. Remember guys, when you're plugging this into your calculator, don't use the rounded value, use the full 1 decimal. So either don't punch it into your calculator until the very end, or if you punch it in, then just make sure you copy and paste that whole decimal. Yes.
I multiplied all this together, I got like
1/2. Did you calculate in degree or radians? Check your math. Brandon didn't.
I wasn't ready.
Yeah. So guys, remember, very first thing you must do, change it to degrees, especially my calculators. And when you get the calculators on SQL Day, they will all be in degrees. When it gets cleared, it automatically goes to degrees. Or sorry, radians. They'll all be in radians. When it gets cleared, it all goes to radians. So you have to change it to degrees. Okay. Other questions with these two? Yes, ma'am.
Have you ever have to use radian?
Not in geometry. When you get to pre-calc, you'll use radians, and you'll use radians most likely from there on out. In physics, they usually use degrees, though. Yes.
Why does it change the number?
So radians, what it comes down to, I'm going to give you the kind of short, small story of it, is in a circle we have 360 degrees. When we measure it in radians, then your circle measuring radians is 2 pi. So we basically have 360 degrees is the same as 2 pi. So because in degrees, 360, that's a vastly different number than 2 pi. So when you do sine, cosine, tangent, then that yields a different result as well. Yeah. So it comes back to that. It's just a different way of measuring your angle. Just like we could measure length in like inches, centimeters, whatnot. Angles we can measure meter, degrees, or radians. Radians tells about the relationship in terms of pi. Okay. Other questions with this? So our homework that we have is our
Wait, did we go to
review.
the square? What was
Yeah.
the answer?
32.
I can remember that.
Alright, so your review packet, the key was up on Blackboard. You should have checked the key on Blackboard. If you did not, you may pull out your phone right now and check the key on Blackboard. And to go over questions for this, because the key was provided to you, we're going to go back to, if you have a question, write the number up on the board. If you already see the number enough there, then just put a tally mark, and I will go over the ones that need to be spelled. So then start writing questions up here. If you need to look through the key on Blackboard, feel free to do that. And then we'll go over questions from there.
Hang on, I want to see if I can wait. Yeah, but I should
Yep, that's where it be trying to go anywhere else, I'll tell you the course. What's that? No, we're going to be doing more of it. Alright, let's go ahead and take a look at these. If you're still checking and you have questions as we're going through, just go ahead and add throughout the board. Alright, so we're going to take a look at number 7 first. Alright, so it says find the slant height and surface area of the right cone. And I think that says 6. Is 6 my height there, or is it 5? Alright, so I got my height is 5. They give me my circumference here. It's 24.6. And they want us to find the slant height. Okay. So for slant height, we got to think of what equations we can use to find slant height. We know that our lateral area has slant height within it, but we don't have the lateral area given to us. And we know that we can also use Pythagorean theorem. But for Pythagorean theorem, I would need to find my radius. Okay, so let's first find our radius here. They gave us our circumference, so let's take a look at the equation for circumference. It's 2 pi r, which gives us a way to solve for radius. So 24.6 equals 2 pi r, and then you solve for your radius from there, and you get r is 24.6 divided by 2 pi, or about 3.9152116. Again, don't use the rounded decimal, don't just put 3.91 or 3.9. Make sure you use the full long decimal when you go to find the surface area and slant height. All right, so my recommendation when you go to use this is, again, you can either copy and paste or you can store that value in your calculator. Just to refresh our memories of how to store in a calculator. Where's my calculator?
Don't you hit like
That is a great description,
you
Brendan.
hit like store?
Mm-hmm. Yeah, that's exactly it.
You're welcome, everybody.
All right, so we're going to do 24.6 divided by 2 pi. And we can't write it like this in our calculator, because if you type it like this in your calculator, it's going to read it as 24.6 divided by 2 times pi. So we need to make sure we seal that denominator in parentheses. So if you got the wrong answer but you had the correct setup, that might be what you messed up.
Wait, could you also do the alpha y equals then use the n divided by d and then put it into that?
Where it's like the vertical fraction. Yeah. Okay, so that's what gives us our 3.915. And what Brenda's talking about, if your calculator has the update, and mine do have the update, you go to alpha y equals. That first option gives you a vertical looking fraction. And that makes it a lot nicer, so you don't have to worry about those parentheses. So we'll then read it as that 2 pi in the denominator because it is in the denominator. So that was, again, alpha y equals, that's the shortcuts. Great. So to store that, once I found my value, store, and you can choose it store it in for, since it's radius, you might want to do alpha r for radius, you can store it correct. I'm going to go and do alpha r. So anytime I type r, then it'll have that value. Alright, so then we use that with the Pythagorean theorem, and solving we get that our slant height is 6.351, and then it also asks for the surface area. Our surface area is lateral area plus area of our base. We can do area of our base pretty easily now because we have our radius. And then our lateral area is 1/2 slant height times circumference. They already gave us our circumference. And then we just found our slant height. So now it's just literally plugging it into your calculator. Questions with number 7? And these are good types of questions that you'll see on the assessment, on the test, where you have to figure out which equation do you need to use to solve for an unknown value that will allow you to find what they're asking for.
So to find r, did you need to divide by pi?
Yeah, so it's 24.6 divided by 2 pi.
Oh.
Yeah, we didn't have a pi with it, so it's about this. Other questions with 7? Let's go and take a look at 15 next. All right, number 15. I'm glad someone put this up there because we need to look at the part B that was below it. Do we have questions on this first part of finding the circumference and area? No. We're good with that part you need? Awesome. Let's take a look at that. Okay, so this part B down here says find the area of the shaded region for number 15. Okay, so again, we want to, this will be similar to a warm-up we did last class. We want to find our area of that wedge, that sector, and then subtract away from there the area of my triangle. So I've got to find each of those first. Okay, so for my sector, we have that it's 60 degrees out of 360. So what fraction of my circle is that? 1/6, good. So I have 1/6 of my circle, and then area is what we're looking for, so pi r squared. I think we found our radius back when we did 15. Our radius is 12. Okay, so using that information from before, our radius was 12. All right, and then area of the triangle. That requires a little bit of work here. So we've got this is 60 degrees. I'm going to draw in my height, which makes that 30, 60, 30, 60, 90. And if our radius was 12, then that means my short leg here, just this piece, 6. And my height would be 6 degrees. Okay, so area of a triangle is 1/2 my base. Base, again, your base and your height are perpendicular, so my base ends up being 12, 6, 6, 6, 6, 12. And my height was 63. Okay, so let's go from here. Alright, I'm going to go and reduce 6 from my 12, so I'm going to rewrite this out. So 5 over 6 times 12 is 12. And half of 12 is 6 times 6 root 3. Alright, so 12 is 6. 2, 1, 24 pi minus 36 root 3. That'll be, I think, it meters. Is that what you guys got? Oh, you have. Awesome. Very good. So again, this is another example with a triangle where we, because it was not already a right triangle, we had to actually draw that height, that altitude, and find that using 36 and 90. Other questions with 15? Let's go and go back to 9. Okay, find the volume and surface area of this figure. So we've got that combination figure. We have the cone and our cylinder. So volume, you just simply have to find volume of your cone, volume of your cylinder, add them together. So you're just plugging and chugging into your formula. They gave us that our radius was 20, so you didn't even have to do anything strange with that. They gave us our height, so they gave you all your numbers, just plug into your formula. Now for our surface area, if we take a look for the cone, we only need the lateral area of it because that base is no longer surface, it's now inside of our shape. So our lateral area is 1/2 circumference times slant height. We can find our circumference, we've already got our radius there, but the slant height we had to solve for. So our slant height, we end up having to do the Pythagorean theorem with this, and it does not become a very nice number at all. So I would have 2.1 squared plus 20 squared equals slant height squared, so square root of the sides. And that slant height is square root of 404.41, that lovely number. Alright, so when we punch that onto your calculator, we get 1,263.5 as our lateral area for just the cone. So we've got that part taken care of. Now for our cylinder here, we're going to need the lateral area and then just one of our bases, because again, the other base is inside our shape now. So our lateral area for our cylinder, we have circumference times height. Our height was given to us. We can find our circumference. That's pretty easy to find. And then area of the base is just pi r squared. Easy to find. And so then we just had to add all those together. Make sure, again, you don't round until the very end, so add the full long decimals together, because if you round, that could affect your marks. Okay, questions with 9? Alright, so another silo coming at you. Alright, so a silo, just like we had in for our problem last class, we've got that cylinder with that dome on top. And it says, how many square yards of wheat can this silo hold? Alright, so we're talking about, that should say how many cubic yards of wheat. Because if it's void, it's off. So they told us that this silo, it's just a cylinder, so we don't have to worry about how much the dome can hold. So we've got, it's 32 yards tall, base is 12 yards, the diameter, so our radius is 6. Make sure you're careful to catch those on the test, because they won't always give you the radius, sometimes give you your diameter. And then volume for a cylinder is just area of your base times height, so I'm just punching those values. Questions with that one? Okay. Alright, so these last 3, in a moment we're going to be working individually on some problems. So if you were one of these people, just raise your hand, I can punch you those individually. Okay, Let's go ahead and take a look at the paper you had for your warm-up. Let's bring that back. And I want you to flip it over to the back side. There's a change I need you to make on there. See this 10 that's written in there? I'm not sure why that's there. Scribble that out. On the windshield wiper. And this looks crazy. Okay, hold on. There's certain problems I should do, but that's a weird issue. That's like with the windshield wiper. Weird. Yeah.
How long is it? So, okay, might get that one.
No.
Yeah,
That's a good try for me.
no. No, it was too late.
Okay.
Should be a windshield.
Alright. I want you guys to go ahead and do number 11. And then I want you to do 14 through 18. You are welcome to work with your shoulder partner. You've got a new shoulder partner now. And if you were one of these people, raise your hand and I'll come to you during this time to answer those questions.
Yeah. That's it? And even if I do, it's gonna be Vincent, so.
That was a great mistake. Guys, on our review packet, thank you, Megan. Megan pointed out that for number 6, I lost my pi. It should be 324 pi.
I didn't even.
Oh, yeah, I think so. I can say it again.
Pi. Thank
Wait,
you.
so all of these you should be adding in a square right here?
Yeah, yeah. So guys, always have units. If there are no units given to you, put that U, squared U cubed. Did you read the problem?
Yeah, I'm just confused what, like, how am I supposed to find them?
Wait.
Which can't find the area.
What does it say to find the area?
Wait.
Good. So what is it? So it says that a wiper is only 12 inches long. So what is actually getting wiped clean? Only the wiper is, right?
Okay, let's go. Which one? Okay, wait, what? So hold on. Right? Look at that. Where's your line?
So you've got a wiper,
Yeah.
but there's only rubber for part of it.
Okay. I don't know how to interpret.
I believe you do.
That's
I
why I
think,
know.
right? So they go like this.
Yeah.
Okay. So now we're going to wiper, but the rubber is only 12 inches long.
So your rubber's the only one that actually works.
Yes.
That's all I need. Okay.
Again, if you were one of those questions, raise your hand if you come ask or answer this question.
Oh, wait, no.
Right.
Just kidding, I get it. It's like a smaller circle. For those problems from our extended warm-up, I guess? So we had windshield wiper. Okay, so windshield wiper, they told us that only 12 inches is what actually wipes. And so what we had to do is find the area that it's actually wiping.
And so we just had to find the area of the entire big sector and then subtract away from it the part that doesn't get wiped. So the entire big sector has a radius of 14, but the part that doesn't get wiped is a radius of 2, since 12 inches does do the wiping. So you just had to do area of big minus area of small. So you should have done 160 over 3 pi, which works out as 167.552 inches squared. You left it in terms of pi, but did a decimal there. 53 1/3. Pi. But I would just leave it like this. Any questions with number 11? Yes.
On the test, which way do you want us to load the answer?
So you'll leave it in terms of pi unless it says differently. Yeah, so if it tells you to round to a certain amount, the instructions say like round, like for these ones round, then you'll go ahead and do the full decimal. But otherwise, leave it in terms of pi. Yes?
On the test, does it matter if you do the 58 or the 60?
No, you can write either one. It's just this looks a little more chaotic with the 53 or 1/3 in that part, but it's fine if you write that. Okay. Other questions with 11? Okay. So then our bottom ones down here, we're practicing those ratios. And so just a reminder that units, our scale factor is our units, and that's A to B. And then anything that's units squared is A squared to B squared. And anything that is units cubed is A cubed to B. So I'm check your answers here. Number 14, circumference is measured in units, just like radius is measured in units, so it's the exact same ratio. Now surface area is measured in units squared, so you have to square it. And volumes is measured in units cubed, so you have to cube it. Yes.
I'm confused about how much students
Okay, so they tell us 2 cubes have a ratio of 1 to 27 for their volumes. What's the ratio to surface areas? Alright, so my volume is measured in units. Let me break it down here. My volume is measured in units cubed, and they told us the ratio is 1 to 27. So we've got to take it back to units. So I cube root each one. The cube root of 1 is 1. The cube root of 27 is 3. And they ask about the ratio to surface areas. Surface area is measured in units squared. So this is what I'm looking for. So I just square it. Yeah, it's not very exciting number, it just keeps dancing. Other questions on 14 through 18? Yes? Sure. So 15 says volume of the larger sphere of 600 was the volume of the smaller sphere. And we're still using that ratio from number 14. Alright, so the ratio of the radiuses were already over 2 to 5. So we found a ratio of our volumes was 8 to 125. And they told us the larger sphere was 600. So my large sphere was 600, and they want the smaller sphere. Okay, so my volumes were 8 to 125. And the smaller sphere that we're trying to find, my larger sphere had an actual volume of 600. And then we just cross multiply from here. And with these types of problems, it's a typical type of thing to make you have to go back to original units and then ask you a question about something beyond there, either surface area or volumes.
Yes, I thought this was a simple
You should.
Oh, wait.
So don't be tempted to cube root
I
it,
simplified it wrong.
just straight up simple. Other questions on these? And I do want to emphasize what Nikki said. Always simplify your ratio first before you do anything. It'll make it a whole lot easier. And then that way you don't lose points for having an unsimplified ratio. Okay. Let's go take a look at our quizzes. Was there anyone that did not get their quiz back? Okay. Bring that up here.